Welcome to a video on dividing whole numbers. The goal of the video is to perform long division with whole numbers. Let's start by taking a look at a more straightforward example. Here we have 6 divided by 2. We should be aware there are several ways to represent division of whole numbers. Remember, a fraction bar also represents division. And then for long division, we'll set up our division problems in this way. Division of whole numbers means we will take a certain number of items and split them up into groups. So 6 divided by 2 means we have 6 items and we want to divide these into 2 groups. So if we take a total of 6 and divide it into 2 groups, and now we can see that when we take 6 and divide it into 2 groups, each group will have 1, 2, 3 items. Therefore 6 divided by 2 is equal to 3. The number being divided is called the dividend. So in this problem, 6 is the dividend. The number we are dividing by is called the divisor. So in this problem, 2 is the divisor. And then the answer is called the quotient. So for this problem, 3 is our quotient. Now before we take a look at some more involved problems, let's go back and take a look at the multiplication table. A multiplication table can also help us perform log division. For example, if I wanted to know what 56 divided by 8 was, I could use this multiplication table. The first thing I would do is find 56 in the table, which we see here. So if we take 56 and divide by 8, notice 8 is in this column, we can find the quotient by determining the factor in this row. So 56 divided by 8 is equal to 7. And notice there's another 56 in this table. And it doesn't matter which 56 we use. If we take 56 and divide by 8 using this row, then this column will tell us our quotient, which is 7. So this table can be very helpful when we're first learning how to divide. Let's go ahead and take a look at some examples that require long division. So here we have 515 divided by 5. Let's set this up in long division form. So notice we're dividing by 5. What we're going to be doing is determining how many 5s there are in several different numbers to determine how many 5s there are in 515. And the way we do this is we start with the leftmost digits of the dividend and start asking how many 5s are in those numbers. What I mean by that is we start with this leftmost digit of the dividend and ask how many 5s are there in 5. Well, there's 1 5 in 5. So we put a 1 above that 5 and now we multiply. 1 times 5 would be 5 and we place that product below that digit. And now we're going to subtract. Well, 5 minus 5 would be 0. And to create the next number that we're going to ask the same question, we bring down the next digit, which would be the 1. So now we ask the same question, how many 5s are there in 1? Well, there aren't any 5s in 1, so there are 0 5s in 1, the 0 above the 1, and now we multiply again. 0 times 5 would be 0. Now we subtract again. 1 minus 0 would be 1. Notice we have one more digit to bring down, and it's the last digit, which is the 5, which creates the number 15. And now we ask the question again, how many 5s are there in 15? Well, there are 3 5s in 15, so we place a 3 above the 5, and we multiply again. 3 times 5 would be 15, and we subtract. Notice our final difference is 0, and since there are no more digits to bring down, this tells us our remainder. And since the remainder is equal to 0, that means 5 divides evenly into 515, and the quotient is 103. To relate this to multiplication, if 515 divided by 5 equals 103, then it must be true that 103 times 5 must equal 515. Let's go and take a look at another example. Here we have 231 divided by 4. Let's go ahead and set it up, and we're going to follow the same procedure. We're going to be asking how many 4s there are in a variety of numbers to determine how many 4s there are in 231. And we start with the leftmost digits of the dividend. So we start with the 2. There aren't any 4's in 2 because it's too small. So now we go to the next digit and consider 23. How many 4's are there in 23? Well, 5 times 4 would be 20, so let's try that. So we place the 20 below the 23 and we subtract. And as long as this result is less than 4, this 5 is correct. And 23 minus 20 is 3, which is less than 4, so that 5 is correct. Now we bring down the next digit, which is the last digit, which creates the number 31. And now we ask that same question. How many 4's are there in 31? Well, 4 times 7 would be 28. 4 times 8 would be 32, which is too big. So let's use the 7. 7 times 4, again, is 28. Now we subtract. 31 minus 28 would be 3, which again is less than 4, so the 7 is correct. But now notice we do have a remainder of 3. We know it's a remainder because there are no additional digits to bring down. So to show there's a remainder when we divide 231 by 4, we put R3 at the end here. So this quotient would be 57 with a remainder of 3. To relate this quotient to multiplication, what this means is that 57 times 4 plus the remainder of 3 would equal 231. Now let's take a look at dividing by a 2-digit whole number. 1,104 divided by 46. Now we're dividing by a 2-digit number, and these can be a little bit more challenging. So we start with the leftmost digit of the dividend. There aren't any 46's in 1 or 11, so now we consider 110. How many 46's are there in 110? Now that's not an easy question, but this is approximately 50, and this is approximately 100. And I know there's two 50's in 100, so let's try it too. So now we're going to multiply the 46 by 2. 2 times 6 would be 12. Carry the 1. 2 times 4 is 8, plus 1, that would be 9. Let's go ahead and subtract. Notice we have to borrow here. 10 minus 2 would be 8. And then we have 10 minus 9, that would be 1. The result is 18, which is less than 46, so this 2 is correct. Let's bring down the next digit. So we have 184. How many 46's are there in 184? Again, that's difficult to determine, but we can think of this as 50 and think of this as maybe 200. And there are 4 50's in 200, so let's try 4. 4 times 6, that would be 24. Carry the 2. 4 times 4 is 16, plus 2, that's 18. And now when we subtract, the result is 0. Forgot the subtraction sign here. And there are no additional digits to bring down, so this does divide evenly because we have a remainder of 0. So our quotient is 24, which means 24 times 46 equals 1,104. Let's go ahead and try one more. Here we have 12,092 divided by 28. So we start working with the left digits of the dividend. We start with 1, that's not big enough. 12, not big enough. So then we consider 120. How many 28's are there in 120? Again, not an easy question to answer, so let's think of this as 30 and think of this as 120. I know there are 4 30's in 120, so let's try 4. 4 times 8 would be 32. Carry the 3. 4 times 2 would be 8, plus 3, that would be 11. Now we'll subtract. 120 minus 112, that would be 8, which is less than 28, so the 4 is correct. Bring down the next digit, which is a 9. How many 28's in 89? And when I see this, I think of how many 30's are there in 90. That would be 3, so let's try 3. 3 times 8 would be 24. Now we're going to carry a 2. 3 times 2 would be 6 plus 2, that's 8. That looks good because the difference here would be 5. bring down the last digit. So our last question is, how many 28s are there in 52? Let's try 1. 1 times 28 would be 28. We have to borrow here. 12 minus 8 would be 4. 4 minus 2 is 2. 24 is less than 28, so this 1 is correct. We have a remainder of 24. So what that means is 431 times 28 plus a remainder of 24 would equal 12,092. Okay, that's going to do it for this video. I hope you found it helpful. Thank you for watching.